Hi, welcome to the pre-calculus notes on graphs of functions. So this is day 2, and we're going to delve a little more into graphing piecewise functions. All right, so for this first one, we're going to graph two parts of this function. When the x is less than or equal to 1, we're going to graph 4. And when the graph is greater than 1, we're going to graph -3. So if you make a t-chart for each, when you have any numbers that are equal to or less than 1, so let's say -5, 0, and 1, those are all numbers less than 1, the answer is always a 4. So that's this part of the graph right here, including 1 itself. So you'll notice that the point 1 is filled in, and it's a horizontal line to the left. When the graph gets to 1, we're going to have -3. So you'll notice in the y column, all of the outputs are -3, including at 1, but 1 itself is not included because the equal part's not there. So it ends up being a horizontal line through -3 to the right, because it's all numbers greater than 1. All right. Let's try one a little bit harder. All right, so for this one, when x is less than -3, we're going to graph the line -x plus 1. And when the line is greater than or equal to -3, we're going to graph x plus 7. So I made a t-chart and picked some numbers for each. So some numbers that are less than -3 are -5 and -10. I also included -3. To see what would happen, and I want to take the opposite of the number and add 1. So the opposite of -3 is +3, and 3 plus 1 is 4. The opposite of -5 is +5 plus 1 is 6. The opposite of -10 is 10 plus 1 is 11. For this t-chart, I'm going to also put 3, and this part is equal to, so that's where the hole gets filled in, and we want to add 7. So -3 plus 7 is 4, 0 plus 7 is 7, and 2 plus 7 is 9. Graph some points, and you're going to see that it's going to end up being what looks like a V, which usually indicates that it's going to be, it's going to be a function. Okay. All right. Now let's look at the next slide. All right. So this one has 3 parts. So this one has 3 parts. When x is less than or equal to -3, when x is between -3 and 3, and when x is greater than or equal to 3. So this part should be easy. This one's going to be a constant, meaning that it's a horizontal line at -2 going to the left since it's less than or equal to. So that's that part of the piecewise. Then we've got between +3 and -3. So that's this one right here. It's going to be -x minus 2. So at -3, we're going to take the opposite, which is +3. And 3 minus 2 is 1. That's where that number comes from. Now let's plug in +3. So the +3, the opposite is -3. -3 minus 2 is -5. So I put a point there and a point there and just drew a line in between them. But notice I didn't fill them in. Those points are open because their equal part is not there or there. Okay? The equal parts are here and here. Okay, now let's talk about this turquoise graph. So turquoise is when x is greater than or equal to 3. So I picked 3, 4, 5, 6, all these positive numbers, and we want to subtract 4 and square it. So 3 minus 4 would be -1. -1 squared is 1. Plug in a 4. 4 minus 4 is 0. 0 squared is 0. Plug in a 5. 5 minus 4 is 1. 1 squared is 1. Plug in 6. 6 minus 4 is 2. 2 squared is 4. So if we start graphing that, we have a point at 3, 1, a point at 4, 0, a point at 5, 1, a point at 6, 4. All right, that looks like it's going to be a parabola, but we only want that part of it. Okay. And the last one, we're going to graph this 3 parts. So when x is less than or equal to -4, x is between -4 and +2, and x is greater than or equal to 2. So let's do the dark blue first. And that's when we're less than or equal to -4. So I did -4 and a couple numbers less than it. We're going to add 4 and then square. So -4 plus 4 is 0. 0 squared is 0. -5 plus 4 is -1. -1 squared is 1. -6 plus 4 is -2. -2 squared is 4. -7 plus 4 is -3. -3 squared is 9. Awesome. All right. If we graph those points, here's a point at -4, 0. Is that closed, filled in? Yes, that's filled in because it has the equal. -5, 1's here. -6, 4's here. -7, 9's here. Great. Okay. So that is part of a parabola. All right. Between -4 and -2, it's x minus 2, which should be linear, right? So if we just graph 2 points, we can make a line. So I just picked the endpoints -4 and +2. So if we plug in -4, -4 minus 2 more is -6. And we plug in 2, 2 minus 2 is 0. So from here to here, just draw that line. And we don't have the equal parts. So this point and this point should be open. And then the turquoise part over here to the right is when x is greater than or equal to 2. So I plugged in 2 and a couple other points. So 2, 3, 4, 5, 6. We want to subtract 3 and then square it. So 2 minus 3 is -1. -1 squared is 1. 3 minus 3 is 0. 0 squared is 0. 4 minus 3 is 1. 1 squared is 1. 5 minus 3 is 2. 2 squared is 4, and so on. So we're going to graph these points. 2, 1 right here. And it is filled in because that has the equal part. And then right here, 3, 0, 4, 1, 5, 4, and so on. So we've got a parabola, part of a parabola going this way, and that one's filled in. Okay.